So on this first problem, what you're going to do is you're going to actually think about it as x cubed being squared. And if that's the case, x cubed is multiplying itself 2 times, which x to the third times x to the third would be x to the 3 plus 3, which is x to the 6th. So there is a shortcut there where you could have done just simply x to the 3 times 2. Is that going to be the case every time you're doing a power to a power? Yes. Alright, so you could just always multiply your powers together when it's a power being raised to a power. The very first thing I do on this problem is the exponent to an exponent. So c to the 5th stays put, and it's going to be multiplying c to the 3 times negative 2, because power to a power you multiply. And 3 times negative 2 is negative 6. So now that we got c to the 5th times c to the negative 6, I will add those exponents, c to the 5th plus negative 6, and get c to the negative 1. So the next thing we have to do is move it to the denominator. So it's going to be 1 over c to the first power to be a final answer. You don't have to write the first power when you move it to the denominator. It's implied that's there. And that's my final answer. The key idea I'm wanting to point out here is that if you have 2 bases in parentheses being raised by a power, that power of n is going to go on to each base. So it'd be, if a times b is being raised by the nth power, it's a to the nth and b to the nth. Each base gets raised to the nth power. Very first thing I would pencil in and understand though is that there's 2 different bases. One of the bases is 2, one of the bases is x. The 2 is being raised by the first power. Usually people don't write that in, but if you want to write in a first power on that 2, that might help you. So now let's raise both of those bases by the 4th power. So 2 to the 1st to the 4th would be 2 to the 1 times 4. So the first power right here got multiplied by 4. X to the 2nd times 4. Because the 2nd power gets multiplied by the 4 as well. Now you just got to simplify that where it's going to be 2 to the 4th, 1 times 4, and x to the 8th. Now for simplifying, I actually need to find the value of 2 to the 4th, and that's what you could use your calculator for, or you can just do by hand 2 times 2 times 2 times 2. Should be 16. Alright, so 16 x to the 8th is my final answer. First thing, on that first set of parentheses, x is my base. I'm going to multiply its exponents together, negative 2 times 2. So it's going to be x to the negative 2 times 2. Now I'll move on to the next set of parentheses, times. Now, it's a little tricky right there. 3 is to the first power, remember. So it's going to be 3 to the 1 times 4. And x is also to the first power, so it's going to be x to the 1 times 4. And then y will be to the 2 times 4. And I've effectively taken care of all those power to a powers now. So now I'm just going to go ahead and do those multiplications in the powers. That x will be to the negative 4th. 3 will be to the 4th. Then this next x will be to the, I about put 5, 4th. And then that y will be to the 8th. So here you want to combine the bases that are x, because that's the base that occurs twice, so you'll want to bring those together. Usually you don't want your x's to get together in life, but in math it's a good thing. Alright, so 3 to the 4th will be multiplying now x to the negative 4 plus 4, because I'm bringing these 2 x's together by adding their exponents. And y will still be to the 8th. Alright, now we just got to simplify that down. 3 to the 4th times x to the 0 times y to the 8th. And we're going to do a little bit more here. So if you do 3 to the 4th power, you can use your calculator, and that's 81. What's x to the 0 going to be? That's going to be a 1. And so 81 times 1 is just going to be 81 still. And y will be to the 8th power right there. And we're done with that problem.